Okay. Oh wait. So. Oh yeah. I guess that's not true. Okay, so you're in that special spot, making sure to take the stage review problems very seriously and writing all of them down so that you can go back and study before you take the stage. It'd be worth it to not take a final. The terminal side of an angle has this point. What is the tangent of the angle? So how would we find that? Y over x. Tangent is the y value divided by the x value, right, everybody? Yeah. So it would be root 3 over 2 divided by negative 1/2. So dividing fractions easy as pi, flip the second and multiply. So negative root 3 would be my answer. Okay, awesome. So on the stage 2, they might just say, what's the sine? So they'll say the terminal sine of this angle has this point, what's the sine? So you have to remember sine is my y value, so you'd say that. Does that make sense, everybody? They ask the cosine, you just say x. Okay, next problem, it says create a cubic equation with imaginary roots. So write that down. There's many answers for this, but they want you to remember a couple things here. So can anyone tell me what we know? A solution that's imaginary. Isn't a root just a solution, guys? Yes, right? That's what root means, is a solution. So, wait, say that again? Okay, so you're saying that, I like it, yes. That's exactly what they're going to want you to remember. If we have x is equal to I, then what has to also be a root? Negative I. Our imaginary roots and their conjugate have to be roots together. So your two imaginary solutions would be this. Now, can I do another imaginary solution? Can I? No, because they come in conjugate pairs. So does that make sense of why I can't do like 2i as my third? Because the negative 2i would be a solution, and that would be degree 4. Now, could I choose, I could just choose like something really easy, like x is equal to 1, for example, right? But it's got to be something like that. So then this would meet the criteria. So then Rebecca was saying we're going to have, which is exactly right, x minus I times x, because I'd subtract I to get it set equal to 0, I'd add I to get it equal to 0, x plus I, and then x minus 1. And then we would always distribute these through together. So it'll be x squared minus I squared, right? Which is x squared plus 1. And now we'll multiply in x minus 1. So now that would be the right time, because they'll say put it in standard form. And even if they didn't, you would. So that's x cubed minus x squared plus x minus 1. That's a plus sign. Plus x minus 1. Okay, so remember that if you have an irrational root, square root of 3, its conjugate also has to be a root. Negative root 3 would be a root. If you have 2i as a root, its conjugate, since it's imaginary, has to be a root. If you have 10 as a root, its conjugate is not necessarily a root. Only for irrational and imaginary. Okay, good reminder. Okay, so answer this one. So in words, what would my end behavior be? Oh, you need more hint, yeah. Okay, so we know, right, that it's an even degree, so it has same end behavior, either up and up or down and down. Negative frowns, so it's down and down. So there's a picture of, it doesn't matter what's happening in between, we're talking end behavior. So as x approaches positive infinity, f of x is approaching negative infinity. As x is approaching negative infinity, what's our function approaching? Negative infinity. Very good. Okay, so odd degree, if we had x cubed, what end behavior would that be? Let's say it was 2x cubed. Down and up, right? Just like a positive line. End behavior will be the same. It's positive, it's odd degree, so it'll be like a line. Down and up. Okay, that's it. Those are all the stage review problems for today. So now we're going to start today's lesson. This is 10-1 and 10-2. We're going to go through them together today. So 10-1 is focusing on measures of central tendency. You're going to want a place to do some work. So there's not enough room on the worksheet. Okay, so it says people often refer to the mean as the average. The mean is the only one measure of, okay, sorry, let me start over. The mean is only one of the measures considered, I can't read, so I can't see that right now. People often refer to the mean as the average. The mean is only one of the measures considered the average. Did I read that right? That seems like weird. What the heck can't I read today? A measure of the center of the set of data. So guys, if we find the average, we're finding the center of the data, right? Technically. So we're going to be dealing with measures of central tendency. Now, there are different types of ways we can look at the middle of a data set, many different ways. Those are all measures of central tendency. So what this is getting at is finding the mean or the average is just one way to look at the center of the data. There's many other ways. So we can really look at the middle of our data using mean, median, and mode. Those are all different ways of looking at the center of the data. So it says right here, so this is our statistics unit. Statistics is the study, analysis, and interpretation of data. If you really like statistics, if you go into statistics as a major, you can get really good jobs and make a lot of money, and a lot of times it's really pretty simple stuff. So it says one way to analyze data is by finding the measures of central tendency. A measure of central tendency indicates the middle of the data set. Mean, median, mode are the most common measures of central tendency. We already know how to find those, so I'll just remind you. So mean, like how I remember mean is mean people would call you like if they say, oh, you're pretty average, like, oh, you're an average teacher, I think that's mean. So that helps me remember. Mean means find the average. So to find the average, what you do is you add up all of the data values and then you divide that by the number of points you added up. Just a reminder. Median is literally like, if you think of like in the road, the median is the middle of the road, right? So that's literally finding the middle point. Now, to find the median, the middle point, you have to make sure your values are in order from least to greatest. So this one is. So then they count in right here. So halfway between these two are the median in the middle, right? So then you'd add them up and divide it by 2 to find the actual median, since it's right in the middle there, to split it evenly. So basically, how can I split this data set into 2 equal parts here? And then mode is what happens most. Mode is what happens most. The most often occurring, the most frequently occurring values. So right here we have 2 3s and 2 5s. So 3 and 5 are our mode because they occur twice. So because there's 2 modes, it's considered bimodal. That just means there's more than one mode. Bimodal. So bimodal data has 2 modes. Oh yeah, right here. Notice this, it says, and that is true statistically, if you have more than 2 modes, then there's no mode because it's like there's too many data points with multiple. It won't affect your data. Does that make sense? Mm-hmm. So if you have tons of, like if you have 2 2s, 2 3s, 2 4s, 2 5, 2 6, they're all 2, so we wouldn't have a mode because they're all affecting it pretty much the same. More than 2. Then you would say no mode. What makes statistics hard is it kind of comes down to what are you looking for here? Like it depends on the company, what they're asking you to look at and whatnot. So, I mean, if we can find the mean, but then how do you interpret that? Like what does that mean? You know what I mean? So it all depends on what situation you're dealing with and whatnot. Okay, everybody good with that? Okay, so now we're just going to jump right to this new word. Well, maybe it's not new, an outlier. So an outlier is a value that is substantially different from the rest of the data set. If the data is in one variable, outliers will occur at the end. So they're going to be extremes. Like if something's extremely lower than the rest of the data points, then that's considered an outlier. If something's extremely larger than the rest of the data points, that would be an outlier. Now you have to be careful because sometimes outliers will affect your data in an unfair way. It really just depends on the situation. Should we keep the outlier or throw it out? Because, for example, so outlier kind of will take your data set and make it an outright liar. So, for example, that's like one way I think of it. Because, so for example, let me give you an example of this. So a teacher has to get an 80% average of her student stage scores to keep her job, for example. So let's show you an example of an outlier. Which one of these is the outlier? 20. Okay, so this one student got a 20, which is significantly lower than the other students. Now, because of that outlier, should this teacher lose her job? Let's see if she meets the average. So let's read, find out. Here we go. Add it up for me. 75. We're finding the mean. 75 plus 90 plus 99 plus 20 divided by 4. 73.25 is my average. So this teacher loses her job. But in reality, is it fair? So this teacher, being a mathematician, let's say that it was a math teacher, hopefully she would be smart enough to look at her scores and then go to the district or go to the principal and say, okay, now let's think about this. Principal, you're going to fire me because this one student didn't study when these three obviously did what I asked. You know what I mean? This one student is causing my average to go down significantly. Now I'm losing my job over one student. So now let's say that the principal's like, oh, you know what? I didn't think about that. Let's throw that student out and let's find your average because that's kind of making it. Now let's find the average without the outlier. Oh, what is it? Oh, it's 71? Okay. 71% with the outlier. So what's the average without the outlier? 75 plus 90 plus 90? 88%. So really, this teacher is a dang good teacher. In fact, way good teacher, and they would have lost their job if the teacher wouldn't have looked and said, we should throw out this outlier. Does that make sense, everybody? So that's why statistics is important because of things like this.
You know what I would do?
What?
I consider everything
Well, that wouldn't be true because an outlier really is like an extreme. Does that make sense? It couldn't be. You can't just pick, if that makes sense. All right, I'm going to give you a second to do 1 through 6. Okay. So now if I said you find the range, it just means what is your data, of your data values, what's it ranging between? Like what values is it ranging between? So to find the range of a data set, you take the greatest and the least number and subtract it. So you'll take 12 minus 2 is 10, right, obviously. So this is ranging over 10. Does that make sense, everyone? So our range is 10. Now the median, so let's find the median here. Median means middle here. So watch what happens, guys, because we're going to have a couple of things that are a little bit different happen now. So our median means middle, correct? And 3 this way and 3 this way, it's going to be between there, correct? So you would do 5 plus 8 divided by 2, so 6.5. So our median is 6.5. Now we can take, so we have now what we're going to look at, and we have a lower half of the graph, and we have an upper half of the graph, of the data set. So we have this lower half of our data set and this upper half of our data set. Let's find the median of the lower half, the middle of the lower half. So what would it be? 3. So there's our median. 3 is our median of the lower half. And our median of the upper half is 10. So now that is where you're going to get these quartiles. So this is considered quartile 2. A box and whisker plot, yes. What was the what? Just if I said to you what's the range of the data set, that just means what's the values that this is ranging over. So we took 12 minus 2. The highest value minus the lowest value. So this is ranging over over 10 values. Okay, so our quartile, this is what's called quartile 2, your median overall. Quartile 1 is the median of the lower half, and quartile 3 is the median, the middle of the upper half here. So if I said to you find the interquartile range, that means with these inner quartiles, what is the inner quartile ranging between? So you would take the largest minus the smallest. So you would do 10 minus 3, or Q3 minus Q1, quartile 3 minus quartile 1. So in this one, our interquartile range would be 10 minus 3, which is 7. Yeah, so there's a lot of reasons that we would want to find this. You know what I mean? to be honest with you though. Like, so if you went into stats, you would go into why, like, let's say you went to college and went into stats. They go into how this would be useful, and for a company, just, it depends. That's what's so hard about statistics, is it's like, it could be used for many different things. You know what I mean? That might be a more accurate range. So it just depends. Like, what are you looking at? I can't think of a specific example. Like, is that range a better one to look at, or is 10 a better one to look at? It all just depends on the data set and what you're talking, if that makes sense. It's kind of hard to say. I'm not very good at coming up with an example with statistics. I'm like, oh, I can see how it could be used, but anyways. So let's review box and whisker plots. It sounds like you've done it before. So this is what a box and whisker plot looks like. So you have your box. The median is the middle part here. So the overall median would be quartile 2. Then this quartile 1 is the end of your box. Quartile 3 will be the upper part of your box. And then you have your little whiskers, and then they connect to your minimum value and your maximum value. So min, max, quartile 1, 2, and 3. So if you have a box and whisker plot, you know a lot of things. You know the median, the min, the max, and then you can find the interquartile range because you can do Q3 minus Q1. And looking at the middle of a data set might be more accurate if you're talking, I don't know, I was trying to come up with an example anyway. All right, I'm going to just show you how to really use your calculator to do this. So we could do this by hand, but let's just use our calculators. Okay, pull up your calculator. Because it was all messed up from the polar coordinates, so I went down and reset it. Oops. You do second plus sign, second memory, and then go down to reset, number 7. Yeah, I do. I'm resetting mine because it was all messed up from polar coordinates, and it's too hard. Plus sign. This is a good question. So where we already had this information, we can now draw our box and whisker plot of this. So we could draw our little box. Our Q1 would be at 3. This would be at 3. You know what I mean? On our number line, this would be at 3. Quartile 1, and then our middle is at 6.5. So 6.5. Q3 is up at 10, so not drawn to scale very good here. And then our minimum is 2, so it's just going to be down a little bit to 2. Does that make sense? Min. And then our max is 12, so out 2 units. That would be 12. That would be our box and whisker plot for this. Okay, so everybody on your calculator, watch carefully so I don't have to tell you each 10 times. I'm going to show you how to make a box and whisker plot on your calculator. You'll do second. The first thing you're going to do is see how the stat plot up here. Hit seconds, y equals, so stat plot. We're going to go in here, hit enter into number 1. And notice you can plot, you can make all these different types of graphs. Here's a box and whisker plot with the outliers in it. And here's a box and whisker plot throwing the outliers out. So anyways, let's just do it with it in for right now. Because they didn't tell, I mean, there's nothing saying to throw out the outliers. Okay, so I'm going to go down here and hit enter. Okay, so now I can get out of there, hit second quit. Now you're going to hit stat. So we're dealing with stat, stat and stat, stat and stat. So you're going to hit stat and then edit. And in list 1, you're going to type in all your values. So let's make a box and whisker plot for this. So you'll hit 16, enter, 12, enter, 11, enter, and so on. Numbers, so it'll be quicker. Oops. Now you're going to hit the stat key again. No, actually, I don't even think we need to. We're just going to hit graph now. Oh, but you know what? We're going to need to change our window. That's what it is. So let's go to window. Our X-min is a little bit smaller than our lowest value. So our lowest value was 11. I'm going to make it like Sure, 8. And then our x max, we need to be a little bit higher. Okay. X scale, I'm fine with working in 1s for this. Our y, we don't need to see into the negatives. It's put it in the positive, but it doesn't really matter. 0. Y max, I'm just going to make it 1. Graph. Me either. Did I turn my plot on? Oh, I didn't turn my plot on. I have to hit on. So go back to I went to stat plot and I didn't have my plot turned on. That's the first thing you need to make sure you do. Now I hit graph. So go to, let everybody watch. So go to, make sure that that says on. Then you go to your window and I always make, I'm going, that's as far down as it goes. I don't know. Okay, so there's my box and whisker plot. Now notice if you just hit the word, look, just hit trace. Now it's going to give you the median. You don't have to find it by hand. Now you drop down, there's quartile 1 for you. There's our min. You can just scroll over. Quartile 3 is 19 and our max is 20. So it's a lot of just calculators. Okay, awesome. Okay, so we're just getting familiar with a lot of vocabulary, figuring out how to use the calculator. Okay, percentile. You might want to write this word down. So a percentile is a number from 0 to 100 that you can associate with a value x from a data set. It shows the percent of the data that are less than or equal to x. If x is at the 63rd percentile, then that means that 63% of the data are less than or equal to x. What? Oh, okay. So just say this, like, okay. So percentile. Write this down. Percentile. So a percentile is the value of which the data values are below it. So if you have if it's at the 63rd percentile, it's pretty high up there, right? That means 63% of the data is below it. From 0 to 100. So if it's at the 100th percentile, isn't that the highest value? 100% of the data will fall below it. That's what that means. At or below it. So if it's at the 100th percentile, that would be the largest value because 100% of the data will fall below or at that value. I don't really know how to simplify it. Very good. So you're right. Height and weight of birth of children. I remember that was an example in the book. They said that exact thing. So, and then also like they'll even tell you on like your ACTs and stuff sometimes, or mostly SATs. They'll say you're at the 63rd percentile of your class. So you know that you're 63% of the students in your class are below you. Does that make sense, everyone? So that's not the worst. It could be worse. Okay. So here's an example. So here's what you got to understand. To find the correct percentile, it has to be ordered in least to greatest. So this data set is ordered in least to greatest, and these are midterm test scores for a Spanish class. What value is at the 65th percentile? So first of all, we need to figure out how many data values there are here. So there's 20 values. So to find what we're talking would be at the 65th percentile, you'll take your 20 times it by 65%. So we know to do that using like math, we have to do 20 times 0.65. That's 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There. That and below, 82 would be our 63rd percentile. 65th percentile. Does that make sense? So 82. We haven't got there yet. So 13 values fall at or below 82. So that's 65% of the data will fall below 82. So not, and which makes sense, look at it, like more than half fall below 82. So it's all making sense. Okay, do we need another example of percentile or no?
Yeah.
So looking at these, they're in order. So it says, what is the value of the 55th percentile? This is 20 values again. So times by 0.55. How many values in do I need to go to be at 0.55%? Yep. So in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 79 would be at the 55th percentile. So that means 55% of the data falls at or below 79. All good?
Yeah.
Okay, what is the value of the 95th percentile? So you'll take 20 times 0.95, 19, so that would be 98. So 95% of the data will fall at or below 98. So not that many above 98. 1%. All good? Okay, finish 10-1 and then we'll move on to 10-2. What? For what one? More? No. Okay, so now we're on to 10-2, standard deviation. So, standard deviation is a measure of how far the numbers in the data set will deviate away from the mean. Remember, mean means average. So, how far the numbers in a data set will deviate from the average of the data set. In the previous lessons, we studied range and interquartile range. We found the range and the interquartile range. And each of these is a measure of variation, which makes sense, guys. If I say, how do the numbers vary, then like, what is it ranging over? So a measure of variation describes how the data in the data set are spread out, which makes sense. It describes the spread. If it's varying between 10, it's spread out over 10. Does that make sense, everybody? If it's ranging over 10, it's spread over 10. So variance and standard deviation are the measures showing how much the data values deviate from the mean. So you're going to see it written as Greek letter sigma. Greek letter sigma is the standard deviation, and sigma squared is your variance. So sigma is standard deviation, sigma squared is variance. So if you know the standard deviation, you just square it, and that will give you the variance. And then also, just for notation, in statistics, a lot of times they'll write the mean, which means average, as x bar. That's just how they like say find the mean. If they say find x bar, that means find the mean. So note that. All right.
Wait, what's that? Sigma?
Yeah, that's sigma. Okay, so if you were in a stat class, and some of you will be taking college level statistics, you will be using these formulas. And I remember literally my entry level statistics course doing all of this by hand. So it's not hard though. It says find the mean. So this is how you find by hand variance and standard deviation. You don't even need to write it down. I just want to show you that you could if I asked you to. So this is what you would do if you were in a statistics class. But really, in here we're just trying to get you to be able to like do it. So we know how to find the mean. That's what we would call x bar. Then we would take all of our x values and subtract the mean from that. So we will find all the x minus x bars, all the values subtracted by the mean. Then we would square each of those values, and then we would find the average mean of these squares. So the variance will be this formula. Sigma squared is the sum, we know that means the sum, of all of our x minus x bar squares. So we would find all the x minus x bars squared, them, and then add them up, sum them up. And then we would divide by that by the number of terms. So then obviously we would, to get sigma alone, we would square root both sides, and that would give you your standard deviation. I literally remember doing this all by hand in my college entry-level statistics class. So, like for example, I just want to show you, and then I'll show you how to do it with your calculator. So if we were going to use those formulas to do this, we would find our mean. That would be x bars. So you would add up all the values divided by the number of values, 5. So our mean is 7.4. So So we have all of these values. These are our x values. Then we have all of our x, we have x bar, our mean. Now if we took x minus x bar, we would get these values. Then we would square them and get these values. So then you would sum those values up. You'd add up this lane right here. Does that make sense, the sum? You'd add up that lane, and then you would divide it by the number of terms. So divide it by 5. That would be sigma squared. So you could use that formula to do it by hand. Make sense? Okay. And then you would just square root both sides of that, because that's sigma squared. That's the variance. You would square root both sides, and you'd get 1.5. So that would be your standard deviation. However, I'm going to just show you how to do it in your calculator. So let's do this. It says, what's the mean, variance, and standard deviation? You could find the mean by hand. You could even do the others by hand. But I'm going to just show you how to quickly type it into your calculator. So pull up your calculator real quick. And you already actually know how to do this. Go to Stat and Edit. In list 1, type in those values. So I'm going to scroll down so you can type those in. In list 1, type in 52, 63, 65, 77, 80, and 82. So now that we have those typed into list 1, you're going to hit the Stat key again. And you're going to go over to Calculate. Now we're only dealing with one type of, we're only dealing with one variable here. We're looking at one set of points, right? So that's called a one variable. We're going to look at the one variable statistic. So hit enter. And then hit enter again. Now look what it gives us. It gives us x bar. It gives us our mean, our average. It gives us this 10 point. So this is, we're not going to use S. We're going to use sigma. So this is our standard deviation, 10.7. N is the number of terms. We have 6 terms. Now look, if you scroll down, it will give you the x min, quartile 1. So we could even draw a box and whisker plot from this, right? Quartile 1. There's our median, which means the middle of the data set. Our quartile 3, which would be the top part of our box and our whisker plot, and our max. So the end would extend out, our whisker would extend out to 82. So really, you don't even have to know how to make a box and whisker plot. If you can generate the one variable statistics, you can then draw your own. Everybody good? Okay, so I need to keep those up for me. Okay, so what is our mean? I'm going to write it with notation. What's my mean? 69.8, okay? What was our variance is sigma squared. We don't know that. We do know our standard deviation. What was our sigma? 10.7. Okay, let's do 10.7. Now to find the variance, you'll just square that. So 10.7 squared? Instead of doing what? Watch, I want to know. Oh, cool. I've never known that. So you said, so second stat, go, oh. Cool. Variance of, you said push enter, enter. Oh yeah, so you gotta put in that you want list 1. Second 1. Maybe, here's the thing, I think, oh, okay. Oh, that's the wrong variance. No. But I would maybe be careful and type even a couple of decimal places. So it was 10 point something, something, something squared, just to be a little bit more accurate. Yeah. Well, okay. And I remember, oh, I should have looked this up. So there's 2 types of, I could look it up. Let me get back to you real quick. It's in my book. It says, I just haven't looked at it since last year. But there's 2 different standard deviations, and we use the one, and I can't remember what. Let me look that up. Okay, perfect. Okay, so now it says, so everybody listen, in a data list, every value will fall within some number of standard deviations from the mean. For example, if the mean is 50, so if the average is 50, and the standard deviation is 10, then the values within 40 and 60 will fall within one standard deviation from the mean. Does that make sense? So if we have a mean of 50, and our standard deviation is 10, everybody. One above that, one standard deviation above that, and one standard deviation below that. That would put me at 40, 60. So any value that falls in this here or here would be within one standard deviation. So if I said to you, what value is 55? Within how many standard deviations is 55 from the mean? You'd say 1, correct, everybody? Let's go out another standard deviation. So what would we be at? 70, and then our second standard deviation. So if I said to you, within how many standard deviations does 33 fall from the mean? 2. Does everybody understand? Now 40 is within one standard deviation. So that is within 1. Does that make sense? Okay, all good. Okay, so let's do this one. It says within how many standard deviations does all of the data fall from the mean? So it says the mean length of Beethoven's 9th Symphony is 37 minutes, and the standard deviation is 12. So we can do this a couple different ways. We could just draw a chart kind of like I drew up there. So, right, 37 plus 12, that would be one standard deviation. That would be at 49. Add 12. So that would be 2 standard deviations, 61. Let's stop there. We could go even more, or let's even go one more, 3 standard deviations. Everybody understanding what I'm doing? So let's go one below. Okay, and then let's go 2 below.
13.
I don't like that that's blue and blending. Okay, I'm not going to fit third. So now let's do this. Here we go. So 27 falls where? Right here, right?
1.
Okay, 30 falls right here. And 47 falls right there. 35. Okay, 30. Oh, we already did that. 40. 35. 22.
Yep.
And 65. Oh, it's a good thing we went 3 standard deviations because that would be here. So what would our answer be? Within how many standard deviations does all of the data fall from the mean? 3. Isn't all of the data sets, isn't all of those values fall within 3 standard deviations of the mean? Yes, so you'd say 3. Most of them fell within 1 standard deviation, but it said within how many standard deviations did all of the data fall? 3 standard deviations. Okay, that's it for the most part. We don't need to do another example like that, right?
Oh.
Okay. Okay, what about this one though? It says, how many standard deviations does all the data fall within the mean? So do you see how we weren't given the mean or the standard deviation? You'd have to type it into list 1, do your for 1 variable statistics, find your mean and standard deviation, and then use that to work it. Does that make sense? You'd have to figure out the mean and standard deviation if it doesn't give it to you. So I'm just curious. I mean, I don't know. If you don't need me to go, talk about this. Okay.
No.
Wow. Why are you such a butthead? What's my mean? Anybody got it yet? So my x bar, my mean is 6.5, okay? Then what's my sigma? 3.2. So we could go through and find this one. So our highest one is 12, correct? Let's just go about this the quickest way as possible. So you'll do 6.5 plus 3.2 plus 3.2, still not, oh, there it is. 2 standard deviations to get to 12. Oh, no, yeah, 12.9. So then you'll do, and then 2 is our lowest, so 6.5 minus 3.2 is 3.3, still not there. So minus 3.2, again, is 0.1. So within 2 standard deviations. So these ones are all really close. So it makes sense, right? If the further out, let's say it took 5 standard deviations, you have some values that are clear out there. There may be outliers, right? Think about it. Okay. Okay, finish the worksheet.